Test 11 review covering Module 11 on matrices. Question 1. Use a matrix to organize the data. So here on the bottom we have a table showing four different kinds of drinks, and there's 3 different kinds of sizes you can have. From that table we can create a matrix. And our matrix, the rows, are going to be the types of drinks, and our sizes is going to be the columns. So right now I just drew my matrix here. Now part B says what are the dimensions of the matrix. The dimensions are always going to be the rows times the columns. So my rows is 4 and my columns are 3. So these are the rows and then these are the columns. Part C says, what is the value of A42? So now when you're looking at a matrix, the first number of the element is your row. So I got to look at row 4, which row 4 is the coffee row. And then I got to look, the second number is the column, which is the medium. So if I look at where those two meet, this is actually at $1.10. And what does that represent in here? It represents the cost of a medium coffee. Question 2, create an incidence matrix for the graph. So here I have a diagram here with vertices and edges. The vertices are going to be my letters, which is my rows, and then my edges are going to be our numbers. So how an incidence matrix works is we want to find out which vertices have an edge to it, which means which edges or vertices have a line leaving from it. And if it has a line leaving from it, then we're going to put a 1. If it's not attached to the specific vertex that we're looking at, then we would put a 0. So I'm going to start at vertex A. And here I can see at vertex A, 1 is attached to A, so I'm going to put a 1 here. 2 is attached to A, so I'm going to put a 1 there. 4 is attached, so I'm going to put a 1 for 4. And then 6 is attached to A, and I'm going to put a 1 there. 3 and 5 do not touch A, so I'm going to put a 0 here. Then I'm going to go to B. B, I have a 1 that's leaving there, so I'm going to put a 1 here. And then I have this one, which is 5, and I'm going to put a 1 for 5. No other edges touch letter B, so I'm going to put zeros for the remaining. Next we have C. So we know 2 touches C and 3 touches C. So I'm going to put a 1 for 2 and 3. Everything else is zeros. Next we start with D's. We have a 3 for D and we have a 4 for D. So I put 1s for 3 and 4. Everything else are zeros. And letter E, we have a 5 and we have a 6. So I put 1s for 5s and 6 for E, and that would be, the rest would be zeros. So that would be our incidence matrix for this diagram. Question 3, find -3 times H. So in this case, -3 is the scalar, and we're going to multiply that by matrix H. So to do that, I have my dimensions are still going to be the same. It's still going to be a 2 by 2. So I have a -3 times 2, which gives us a -6. -3 times -12 gives us a positive 36. -3 times 5 is -15. And -3 times 0 is 0. Question 4. Find the following. So here we're going to multiply by the scalar and then add the matrices. And just keep in mind, in order to add or subtract matrices, they have to have the same dimensions, which they both have a 2 by 3. So the first thing I want to do is just multiply the scalar. So 2 times 0 is 0, 2 times 3 is 6, 2 times 3 is 6, 2 times -2 is -4, 2 times 1 is 2, and 2 times 6 is 12. From that, now I can add this other matrix, and I'm just going to be adding the elements that are in the same location in each matrix. So I have 0 plus 1 is 1, 6 plus 6 is 12, 6 plus -1 is 5. Next row I have -4 plus 2 is -2, 2 plus a -3 is -1, and 2 plus 1 is 3. So that would be my solution matrix. Question 5 says find G times H, and then they give us the matrices for G and H. Now for multiplication, we just want to verify that we can multiply them. So this is a 2 by 2, and this is also a 2 by 2. And when you're multiplying matrices, you just want to double check that these middle two numbers are the same, which they are. That means our answer is going to be what's on the outside, a 2 by 2. So my answer is going to be a 2 by 2. So to do this, this piece right here is in row 1, column 1. So I'm going to take 1 times 5 plus 3 times 9. And that's going to give us 5 plus 27 is 32. Next, this is in row 1, column 2. So row 1, column 2. So I'm going to multiply 1 times -2 plus 3 times 4. So that's -2 plus 12, which will give us a positive 10. Next, I have row 2, column 1. So this would be 8 times 5 plus -4 times 9. So that's 40 plus -36, which is going to give us a positive 4. And our last one, this one is in row 2, column 2. So for these, I'm going to do 8 times -2 plus -4 times 4. We have -16 plus a -16, which is going to give us a -32. Question 6 says find the determinant. Now you can see that the symbols on the outside, these are just bars. They look like absolute value, but these are not. This is talking about the determinant of the matrix. So to find the determinant, I'm going to start in the upper left-hand corner, and I'm going to go diagonally and multiply. So 3 times 4 is 12. And then I subtract, going diagonal the other direction, starting the lower left. -2 times -6 is a positive 12. And 12 minus 12 is equal to 0. Question 7. Find the area of the triangle with the vertices located at 0, -1, -2, -6, and 3, -2. Now, area of a triangle is found by taking 1/2 times the base times the height. But here we don't have any diagram. We're just told the vertices that you could use on a coordinate plane. Now for this one, an easier way to doing this would be just to draw a matrix, and this would be a 3 by 3. So to do a 3 by 3, I'm going to take each vertice and we're going to put them as, so the first one is going to be 0, -1. And then to make it a row of a column of 3, the last one's going to be 1. And the reason why the last one's going to be 1 is because we want to make sure that we don't change any of the values. And when we think about multiplication, anything times 1 is itself. Then we take the next point, and this would be -2, -6, and then we put a 1 here. And our last vertex is 3, -2, and then a 1. Now, if we were to do with matrices, if we were finding the determinant, which we are going to have to do the determinant here, if I have a 3 by 3, there's going to be some numbers I'm not going to be multiplying. So I have to repeat the first two columns in each row. So this would be 0, -1, -2, -6, and 3, -2. Now, since we are going to be finding the determinant is going to be actually what your base times the height is going to be. And then the last step would be just divide by 2. So we're going to start with the upper left-hand corner, and we're going to multiply on the diagonal. So 0 times -6 times 1 is 0, plus -1 times 1 times 3 is -3, plus 1 times -2 times -2 is a +4. And if I combine them, that gives me a 1. Now going in the other direction, I start in the lower left-hand corner, and I multiply on the diagonal, which is going to give us a -18, plus -2 times 1 times 0 is 0, plus 1 times -2 times -1 is a +2. If I add them together, it gives me a -16. And with the determinant, I take my two answers and I subtract them. So 1 minus a -16 equals 17. And because I'm finding the area of a triangle, I just divide that by 2, and we're left with 8.5 square units. Next, solve a system using Cramer's rule. So you've already solved a system of equations using substitution, elimination, and graphing. This is another method you can use, but using matrices. So we have a coefficient matrix. So the coefficient matrix is just the coefficients of the two variables. So the denominator is going to be our coefficient matrix. So I have 3, -4, 2, 5. And then the numerator is also going to have a matrix, but we're going to substitute the solutions in for the variable that we're trying to solve. So this one I'm trying to solve for x. So I'm going to put 26 and 2 for the coefficients of x. The y coefficients stay the same. So -4 and 5. And all I have to do is find the determinant in the numerator and the denominator. So I have 26 times 5, which is 130. And then this will be minus 4 times, or -4 times 2 is -8, which is going to give us a total of 138. Now I do the same thing in the denominator, find the determinant. So here I'm going to have 15 minus a -8, which gives us 23. And then I divide my two answers. And that's going to give us x equaling, if we grab our calculators here, we have 138 divided by 23. That gives us 6. So x is going to equal 6. And then find what y equals. We have a matrix in the top, but we're going to substitute 26 and 2 for our y value. So 26 and 2 go here, and 3 and 2 go here. The denominator, the coefficient matrix stays the same. So since we already found that the determinant down there is 23, I'm just going to keep that at 23. So now I find the determinant on the numerator. So 3 times 2 is 6, minus 2 times 26 is 52. 6 minus 52 is a -46. And we're going to divide all that by the determinant of the denominator, which is 23. That leaves us with y equaling a -2. Question 10. Solve the system using Cramer's rule. For this one, we are not actually going to use Cramer's rule because there's a quicker way that we can solve this system of 3 equations with 3 variables. And that way is using the inverse matrix. So to do that, we're going to grab our calculators and we're going to go to our matrix. So second inverse. I'm going to go over to edit, and we wanted this to be a 3 by 3. And you'll notice that I already have all the numbers written in here, so these are all the coefficients of this matrix. So then I have to do the other matrix, which is going to be our solutions matrix. So I'm going to hit second inverse. We're going to edit, and we're going to go to edit matrix B here. This one's a 3 by 1, and I have my 14, negative 19, and negative 5 here. So what we're going to be doing here is really we're finding the inverse of the coefficient matrix, and then we're going to be multiplying that by the solution matrix. So to get out of here, I'm going to hit second mode, and then I'm going to go back in here. So second inverse, and I'm going to choose matrix 1, and we got to do the inverse. So I hit the inverse button, and we're going to multiply that by the second matrix, so second inverse, and matrix B, so number 2. And then if we hit enter, it tells us our x, y, and z. So our x is negative 1, our y is 0, and our z is 4. So you can either put it as a matrix of negative 1, 0, 4, or you can say x equals negative 1, y equals 0, and z equals 4. Question 10, we're going to find the inverse of this matrix. So for this one, we're not going to use our calculator for. You could still use your calculator to check your answer, but we're going to do this by hand. So to do this, we need to first find the determinant. So 2 times negative 6 is negative 12, minus negative 2 times 10, or negative 2 times 5 is negative 10. So negative 12 minus negative 10 is a negative 2. And since we're trying to find the inverse, we have to take the inverse of negative 2, which would be the reciprocal, and that would be negative 1/2. Then we're going to multiply that by a rewritten matrix. So when we do this, we're going to switch these two parts around. So this will be negative 6, and the lower right is 2. And then we change the signs of the other numbers. So this would be negative 5, and this would be a positive 2. And then we treat this negative 1/2 as a scalar. So negative 6 times negative 1/2 is a positive 3. Negative 1/2 times negative 5 is positive 5/2. Negative half of 2 is negative 1, and negative half of 2 is also a negative 1. So that would be the inverse. Now, if we want to just verify that that is correct, we can go back to our calculators, go back to our matrix. We're going to edit, and I'm going to just edit C. So this is a 2 by 2. Let me put our numbers in. So 2, 5. We got negative 2. And then we have negative 6. Now we get out of here. And then we go back in. So it's second inverse. And the determinant, we're going to go to math. And that's option 1, determinant. So that's 1. Then we go back to our matrices. And then we have number 3. And that gives us a negative 2, which is what we found here. And now if I were to take the reciprocal of that, so a negative 1 divided by 2, and if I multiply that by our matrix, and we're going to have to edit number 4. This is a 2 by 2. We got to put their new numbers in here, so this would be negative 6. -5, 2, and 2. And if we get out of here, and then we go back in, and we have matrix 4. If I hit enter, there we have our 3, 2.5, which is our 5 halves, -1 and -1. Our last question, here we need to solve the matrix equation. So we're going to do the same thing that we just did with the one where we're solving 3 equations with 3 variables. We're going to do it the same way, but I'm going to show you how you can do this pencil paper method, and then I'll show you how you can do the rest of it on your calculator. So the first part is we need to find the determinant of this first matrix. So 1 times 1.1 is 1.1, minus 3 times 1 is 3. And this is going to give us a -1.9. Now we need to find the reciprocal of that. So on our calculator, we did 1.1. Then we're doing minus 1.9. Actually, not minus 1.9. So let me do that again. So 1.1 minus 3. That gives us a -1.9. If I do the reciprocal of it, I just have to do the inverse of -1.9. That gives us a really long decimal, but putting it as a fraction would give us a -10/19. So we have a -10/19. And then we have to rewrite this first matrix. So this would be 1.1. This is -1, -3, and then 1. And then we just multiply all of those. So -10/19 times 1.1. So we multiply this by 1.1 as a fraction. Gives us -11/19. -10/19 times -1 is just 10/19. And then we know this other one will be a -10/19. And now the other one, we have -10/19. And we're going to multiply that by a -3. That's going to give us a positive 30/19 should be. So 30/19. So that's going to be our matrix here. Now for the rest, all we're going to do is take the inverse, take this and multiply it by this matrix here. And so we're going to do this on our calculators here. So we gotta go back to our matrices. We know it's a 2 by 2. So I'm gonna edit the 2 by 2. So I'm gonna edit number 3. So we know it's a 2 by 2. We're gonna type these in. So this is a -11 divided by 19. Next one's a 10 divided by 19. Then we got 30 divided by 19. And then we have a -10 divided by 19. Then we have to edit the other one. So second matrix, we're going to edit. And the other one's going to be a 2 by 1. So I'm going to do edit number 4. So this is a 2 by 1. So we have 16.4 here. And we got 38.94. Now for this one, if I now get out of here, second mode, then we go back in, second inverse, we have number 3. And we're going to multiply that by number 4. And here we have our answers of 11 and 5.4. Now if we were to do this all completely by hand. I'm going to put this other matrix here, so negative 11/19. Actually, we're going to just multiply this by 16.4 and 38.94. So we have row 1 times column 1. So that's going to be negative 11/19 times 16.4. And we're going to add to that 10/19 times 38.94. And since we already did the work on our calculator, we know that that equals 11. And the other one's going to be row 2, column 1. So this would be 30/19 times 16.4. We're going to add to that negative 10/19 times 38.94. And we found that to be 5.4. So that would be this would be our solution. So as a quick review on how you can solve problems with matrices.